Hi guys, welcome to this video on algebraic fractions, in particular adding and subtracting. Okay, so there's a couple of different types of fractions when we add and subtract them. One with same denominators and others with different. So the first ones that we'll have a look at will be the ones that have the same. So when you add or subtract, you need the same number of parts. So when we do have the same number of parts, we just add our numerators with the same denominator. So then we end up getting 2x plus 1x, and we have 3x over 5. So we need the same denominator. And we'll have a look later on when they are different, what we'll need to do. Okay, so the next one, denominator will be the same, which is 5. And what do you think we are going to do with the 2x and the 3x? Now, if you said add them together, because we have the operation of plus, okay, adding, you are correct. Now, this type of solution, 5x over 5, is a little bit different to the previous one. Now, if you can go back and remember with any type of fraction, if we have common factors top and bottom, we can divide. So if we had something like a 5 and the 5, well, we can cancel those, divide the top and the bottom by 5, and we end up getting 1x left over. And our third one, we have a denominator of m, and then we just subtract, because we have a takeaway now, this 7 and the 2. 7 take away 2 is 5, keeping the denominator the same. So when we have the same denominator, there's no need to convert each fraction. And when we have different denominators, like we have here, we need to obviously make them the same. So with the 5 and the 3, we need to convert the 5 and the 3 to numbers that are the same. Now, factors come into, multiples come into play here. So if we've got the 5s, we've got 5, 10, 15, 20, etc. And the 3s, we've got the 3, the 6, the 9, the 12, 15, 18, etc. Common will be 15. So the 2x over 5 plus the x over 3, we want to change both of those denominators to 15. How do we do that with a 5? We times the 5 by 3. Need to also do the same thing with our numerator. With a 3, multiply that by 5, and we end up getting our denominators, like the previous questions, with common denominators, or the same denominator. 2x times 3 is 6x, and x times 5, 5x. And like we did with the previous types, 6x plus 5x is 11x, all over 15. Alright, the next one we've got a 3x and a 2x. So before we had a 5 and a 3, we found the common multiple, and over here we need to find what a common multiple is going to be. So if it was just a 3 and a 2, what would be the common denominator there? And if we have the 2, 2, 4, 6, 8, 10. So if you said 6, you're correct. But we have x's with this, so we need to have a 6x. So to make the denominator of 6x for this one, times it by 2, times that by 2, and over here we multiply by 3. So our denominators will be 6x, and our numerator will be 4 times 2 and 3 times 3, and we end up getting 17, because 8 plus 9 is 17, and keeping our denominator the same, because we're looking at equal parts. Okay, and the last one, common multiple of 4 and 6, so 4, 8, 12, 16, 20, etc. 6, 12, 18, 24, etc. Common will be multiples of 12, so the first one will be 12. So if we have 3y over 4, take away y over 6, getting a common denominator, so this one will be 12, so we need to multiply the denominator by 3, and this one by 2 over 2. So we end up getting 9y over 12, take away 2y over 12, 9y, take away 2y is 7y over 12. So what we need to focus on is getting our fractions with the same denominator. And how we do that will be our either multiples, or we could even think about our times tables in our head. That will be the most challenging section of each question. And then following the same process, keeping the denominator the same, equal parts, and then adding or subtracting depending on what the question is. Okay, so that's algebraic fractions, adding and subtracting with same and also different denominators. All right, thanks for watching.